And yeah. Okay, and yeah, so let me just share with you the agenda of today's workshop. So, okay, does everyone see my screen? Is everything okay?
Yes.
Yes.
Okay, perfect. So we will start with our introduction, and we will have a small break around 10:35 CET, and we should be ending our workshop by 12 around 12 o'clock Central European Time. So the introduction will be given by the VITAL-5G project coordinator, Dr. Eleni Yiannopoulou. A few words about Dr. Yiannopoulou. She is the project coordinator of VITAL-5G. She works as a senior solution architect and product manager at Wings ICT Solutions. She received her bachelor's from the University of Thessaly and an MSc in Advanced Information Systems from the University of Piraeus. She obtained her PhD from the School of Electrical and Computer Engineering at the National Technical University of Athens, working with algorithms for automatic information extraction from textual data, utilizing unsupervised and deep learning neural networks. She has been actively involved in a number of international research and development programs under FP6, FP7, CF, and Horizon 2020 framework. Indicatively, some of the projects concern deep health, safety for rails, 5G tours, and VITAL-5G as a technical manager. And she's mainly interested in the design and development of IoT platforms that offer vertical solutions for transport infrastructure. She leads the technical development of the Wings products of Wings ICT Solutions. Thank you very much, and Nelly, the floor is yours.
Thank you very much, Andrea, for this introduction. So I will share my screen. Just a second. Okay. So hello from my side. I welcome you to this workshop on behalf of the VITAL-5G consortium. VITAL-5G is a project which is funded by the European Union. It's a 5G PPP project, the focus of which is to provide 5G innovations for verticals with third-party services. VITAL-5G provides 3 5G testbeds and 3 different transport and logistics infrastructures. In the content of the project, different NetApps are being developed, which will be made available through the VITAL-5G experimentation platform and open repository. The open repository will be open to third-party experimenters in order to build their own applications, leveraging on the NetApps developed by the project. The VITAL-5G concept spans in 3 different pillars. The first pillar is the transport and logistic facilities and also 5G enabled use cases. The second pillar is the 3 different 5G testbeds, namely the Antwerp, Athens, and Danube testbed. And the third pillar is the VITAL-5G experimentation platform and open repository, where the NetApps are being developed and also onboarding deployment and experimentation tools are available for third-party experimenters. The NetApps in the context of VITAL-5G are mainly packages containing NFV descriptors, software images, and configuration scripts for service chains formed by virtual and physical functions. There are 2 types of NetApps: the application-specific, which address specific industry challenges for the transport and logistics sector, and the application-agnostic, which are used to implement core components of the applications that can be reused in other sectors as well. Finally, in the NetApp implementation, the focus is to chain multiple NetApps together in a flexible and reconfigurable manner to provide advanced end-to-end services. For example, the autonomous vessel navigation service is composed by 4 different NetApps. The digital twin and monitoring sensor data NetApps, which are application agnostic, and the obstacle detection and tracking and path prediction and vessel control NetApps, which are application specific NetApps. And with this, this is the end of my introductory presentation. So thank you all, and I hope you enjoy this workshop.
Perfect. Thank you very much, Nelly, for the great introduction. If anyone has any preliminary questions or something similar, please feel free to engage at any time. And the same goes with the presentations. At the end of this presentation, we will have a Q&A session for people who want to ask something. With that, I would like to continue to the next presentation given to us by Nina Slamnik-Kirestorak. So a few words about our speaker. Nina is a university researcher in the field of applied engineering sciences at the University of Antwerp and the IMEC Research Center in Belgium. In 2016, she obtained her master's degree in telecommunications engineering at the Faculty of Electrical Engineering from the University of Sarajevo in Bosnia and Herzegovina. She has authored and co-authored more than 30 publications in journals and international conferences. Her current research is mostly based on advanced network architectures with edge computing for automotive and transport and logistics systems, as well as on the management and orchestration of the flexible, open, and programmable next-generation end-to-end network resources and services. With that, I would like to give the floor to Nina. Thank you very much. Please let me unshare, and the floor is yours.
Thank you very much, Andreas. Good morning, everyone, from me as well. I will quickly share my screen. So as Andreas introduced me, thank you very much for a nice introduction. I will give you a brief overview of the role of the third-party experimenters in the VITAL-5G project. What is their role, what we offer to the third-party experimenters, and how all of that can be realized. So in the VITAL-5G project, we have this capacity building program, which is completely focused on the involvement of third-party experimenters. Any SME, startup, research group, company can be a third-party experimenter for us. And what is the idea? Basically, the idea is that these companies and third-party experimenters try to learn about network applications and how to run them in realistic 5G scenarios to boost the operation, enhance the operation of transport and logistics services. So basically, the whole idea of these networked applications, 5G enhanced network applications, is to improve the operation and to basically remove the gap between the 5G experts and the service developers and software developers. There are different roles for the third-party experimenters in our project. So first of all is to leverage our open source NetApp environment, where we have different NetApp catalogs with NetApps that are already available, developed and designed, and can be reused by third-party experimenters, either to create their own services or to use them as an example how to build their own NetApps. Or of course, as I said, third-party experimenters are encouraged to build their own NetApps with our help and with our guidance, and then of course to test them in a very realistic scenario. This comes to my second bullet point, which is to test and validate different transport and logistics vertical applications through our VITAL-5G platform. Basically, once the NetApp is designed and created, we can run it on through the VITAL-5G platform in one of the port or warehouse environments, and we can test and validate together with you and gather some very important learnings about the transport and logistics services. And of course, we offer valuable assets from the VITAL-5G pilot sites from all three of them, as Nelly mentioned, Antwerp, Galați, and Athens. And later on, not in this presentation, but in one of the presentations today, we will go through all these steps, teaching you about the NetApps, how the NetApps can be created, how they can be onboarded, how the VITAL-5G platform can be used. And then, of course, we also give an insight into three of these pilot sites that we mentioned here. about particular available assets that we give at disposal to the third-party experimenters. More about that can be found on our website, and I will show you where exactly. But our coordinator, Nelly, will also go into more details about these available assets in one of her presentations today. So let me go quickly to how to get involved in our project and where exactly on the project website you can find that. We have a video here. We will make it available for anyone, even for those who are not in the workshop today. I will switch to the video to show you basically on the website, there is a section Get Involved. And on this particular section, you can find more information about engaging with us. And also what are the assets that you can experiment with. So first of all, here we give some brief information about third-party experimenters' participation and about our trial sites, Antwerp, Galati, and Athens. If you click on any of those three, you will find more information about them. But let's go to how to get involved. So first of all, there are different steps. We try to make it very simple for any interested party. There is step one to explain to you how the whole procedure works. So from the design phase, when you want to design your vertical service or your NetApp, until the moment when you collect different learnings and collect different metrics from different pilot sites. So let's start from the beginning. If we check here the vertical service design, if you have an idea about vertical service that lays into transport and logistics sector, or even out of it, but can reuse the concept of NetApps and vertical services, then this is the step where you design your service and define what NetApps are building this vertical service and how these NetApps can be developed. Either developing your own NetApps, as I mentioned, or selecting the ones from our open repository from the VITAL-5G project. Then, of course, this is all about running these vertical services in a 5G ecosystem. So we offer you the opportunity to specify your mobile connectivity requirements. And for that purpose, we will show you later how in NetApp design, this can be also specified. And then, of course, to chain all the NetApps to build a vertical service. This all falls into the first phase of vertical service design. And once you have your design ready, then we proceed with the experiment design. This is the place where we help you, of course, to select the target testbed. We have 3 pilot sites in Belgium, Romania, and Greece. And we have different 5G testbeds for each of these pilot sites. So we define together with you which testbed is suitable for running your vertical service. And then we define and evaluate which are the KPIs that you would like to monitor and what are the scripts that you would like to collect during the experiment execution. Then, of course, there is a need to prepare the facilities and the testbed for your experimentation. And for that purpose, we have persons that are basically responsible for each of the testbeds, and they will help you and guide you on how to reuse this 5G testing environment, how to prepare it for you, and then to run your experiment together with them. Once the whole environment is ready, we proceed with the vertical service instantiation. This goes through the VITAL-5G platform. We prepare the network slices that will be used for your NetApp traffic, and then we configure together with you and activate those NetApps so that the collection of the different metrics can be proceeded. Before we jump further, then of course the experiment execution. During the experiment, we will collect different metrics. The mobile traffic will be running through the network, and then you can create your own test scripts for that purpose to collect data or to derive some conclusions. And then, of course, in the end, we also have AI-based diagnostics features for troubleshooting and offline analysis of the network and service KPIs that are collected in the previous step. And of course, you can also use your own tools for that after the data has been collected. So basically, all these steps are roughly how the procedure works. But of course, the more details depend on the testbed that you choose and the NetApp that you create, but this is just roughly to give you an idea how the whole experimentation with third-party experimenters should look like. More details about that and yeah, all of that I just explained can be found on the website on this particular section that I just showed you. And of course, we need to know what your role will be and what is your particular interest. So for that purpose, we have this form on the same view on the website. We would like to know more about you. Who are you? From which organization type are you coming? And then, of course, we need you to give us a detailed answer on what are your exact needs when it comes to the Vital 5G experimentation. What are the NetApps that you would like to develop? What are the particular vertical services that you are interested in? Which facilities from our project you would like to experiment with? Which 5G testbed, etc., etc. So all of that can be placed here in this answer. But later on, I think in the end of this workshop, my colleague Andreas will provide you with a survey that you can use to also express these answers, your opinion, your view, and basically your preference about different assets that we offer in the project. Regarding step 2, we would like to basically show you here what else you can leverage from the website. In step 2, we offer many events. As you can see, one of them is this workshop that we organized today. We also organize many webinars, and there will be more engaging activities with third-party experimenters. So please keep an eye on this calendar. We will try to keep it up to date. And basically, anytime we have any updates, any event happening, you will be able to find it there. Here, if you click on any of the pilot sites from the website in the third-party engagement section, you can find more information about the available assets. What in particular can you leverage from the pilot sites, and what are the available assets, and when they will be available for the experimentation. The time is also a very important factor here. Not all assets are already available, so please keep an eye on all these 3 pilot sites. Athens is the last one, and here we will go through the details later today in one of the presentations, so I will just skip it for now and just let you know where it can be found on the website. Here, also in the Get Involved section, you can find additional resources or additional material that we prepared. Here, we usually place the recordings of different webinars, demos, and also including this workshop today, we will place it there so that it can be replayed if you missed some information, or if you would like to replay some of the demos and check where did we present our work, on which conferences, and which venues. Please go ahead and keep an eye on this section. Anytime we post something, it will be there. I think this comes to the end of my presentation here. I would like to thank you for your attention and welcome you again to this workshop. I hope you will enjoy more technical sessions that we prepare for you today. Now I give the floor back to Andreas and the next presenter.
Thank you very much, Nina. Thank you very much for the presentation. And yeah, everyone, please feel free to visit the website, engage with it, and we really look forward to receiving your feedback and your expressions of interest, and to see your creativity pour out on the website. Okay, perfect. So without further ado, I will give the, so our next talk is from 2 of our stakeholders that will share their opportunities that were given through them through the Vital 5G platform. We have Najmi Masoudi from CIFAR and Maggie Stamadelatos from the Kinesis. A few words about our speakers. Najmi Masoudi Dion is the R&D director at CIFAR Belgium, a position she's held since 2021. In this role, she sets the short and long strategic R&D roadmap for CIFAR and is responsible for ensuring that the company meets its objectives for researching and developing new products or technologies and improving existing products. From smart to autonomous ships, Najme provides timely guidance about a variety of tech-related matters. She holds a master's degree in cybernetics engineering from Norway, and with her 14 years of experience in the automobile, offshore, and marine industry, she makes a bridge to transfer cross-industry knowledge. Magis Amadelatos is the project leader in the Agenesis with more than 18 years of experience in research and innovation projects as technical and or coordinating staff. He has worked as a researcher in the Department of Informatics and Telecommunications at the University of Athens, and he holds an MSc in Communication Systems and Networks, as well as a BSc in Informatics and Telecommunications from the University of Athens. I would like to first give the floor to Najme. Please, the floor is yours, and thank you for the presentation.
Hello, thanks, Andreas, for a nice introduction. I'll share my screen first. Okay, and I will go to the presentation mode. So hello, everybody, and thanks for being here and your interest in VITAL-5G and the work we do. First, I'll give you a quick introduction of who is CIFAR and what we do here, and what why we have joined the VITAL-5G project. So CIFAR is a technology and service provider in inland navigation, in maritime business. In inland navigation today, there are shortage of crew. So basically, there are vessels and there is cargo, but there is no more captain to go on board and navigate the vessel to transfer the cargoes. And also, due to that, there is an investment needed to meet the sustainability targets. Fleet has to be renewed because the average of fleet age in this sector are between 30 to 20 years. So as you see, they are kind of a big box with an engine on, and they have to meet the new Green Deal of Europe. And the other issue we have here is the low safety record. They say between 60 to 80% of accidents that happens in this domain are done by humans. So we believe that automation can help in this to increase the safety. So CIFAR, the services we are providing is an unmanned navigation. We have already 4 vessels in our fleet that are fully unmanned and fully controlled through the Shore Control Center, either monitored or navigated autonomously. Also, we have a crew-reduced navigation support and crew support navigation, which is both of them can help to extend the vessel capability in terms of operation time. We have already 2 open shore control center. The one that you see here is actually our Antwerp in the north of Belgium. And also we have another one in Charleroi, which is in the center of Belgium. And we are is in our roadmap to open a shore control center in Netherlands and Germany very soon. At CIFAR, we are involved and quite active in lots of R&D research lots of R&D projects across Europe, international and also regional level. So part of Horizon 2020, we are part of a 5G blueprint, VITAL-5G, and also Pioneers. We are quite active in ESA, which is a European space agency, and also North Sea region, which is called INTREG, is also part of the Europe organization. And as you see, we are working very closely with Port of Antwerp, governments and authorities, and also research center, including IMEC, which Nina and some of our partners are coming from. And also Port Excel, which is in Singapore. So just quick introduction to the Antwerp use case. Port of Antwerp is a very busy port. And at CIFAR, we are already operating in this port through 4G. We are assisting the captain we don't go for the fully unmanned and autonomous, but we are assisting the captain to navigate in those areas. And we see lots of challenges using the 4G. So that is why when VITAL-5G came along, we saw that it's a very good opportunity to basically increase the availability and redundancy of our operation and that busy port. So within this use case, we will do the 5G connectivity and slicing, which will help us in order to make available bandwidth and urgent operation go through much faster than 4G. And also we can use the high bandwidth, it means full HD camera speed and sensor data. Because today, again, we have probably between 12 to 15 cameras per vessel. They're on board, and we are sending all of those camera feed to our shore control center. However, sometimes we have to reduce the resolution, but also in future we are planning to put more object detection and avoidance on board. And we believe that with the low resolution, we might impact the safety of using those functions. So for us, it would be better with the HD camera. So there are a couple of net apps will be developed within this use case. You see that the VS5, which is a remote monitoring dashboard that we as CIFAR, we are developing it, and I will show an architecture later. VS6 is an autonomous vessel navigation control, which is done by IMEC, which is mainly of the waypoint trackings. VS7 is the navigation speed optimizer. And VS8 is an onboard data collection and interfacing. And VA4 also is a real-time digital twin that also developed by IMEC. So there are a couple of KPIs for the vertical oriented and network. Also, we have KPIs for services. Here, I already just put the KPIs for the vertical oriented and network. So for us, as CIFAR, as the operator body, is the latency and also the reliability and the bandwidth. So as you see that we have all of them in these KPIs, and we hope to reach them by end of this project. The main issue that we face before actually we define those net apps were remotely controlled monitoring of semi-autonomous vessel. As I said in the beginning of my presentation, if we have this capability, this will reduce the number of onboard person, or the other way, it will reduce the need of the people to be on board. Because we don't want to remove people, but just putting them out of job, but simply there are no people to go on board. So that is the good opportunity here to using the this kind of technology. Also using the navigation speed optimization to schedule and to schedule a better planning for the vessels. So our partner Digitrans, actually, they are getting the information from the Port of Antwerp to make a better speed optimization for the vessel. And then the real-time port control, simulating a digital twin of the port to assist in real-time port control and to foresee the short-term future port status. So each NetApp has its own function, and altogether they can be shown in a VS5 that is developed by CIFAR. So as you see, that's a dashboard that we are developing. So it's a very first draft that you can see. So it's not completed yet. At a glance, I can say that on the far left, upper left, you can see the camera feed that coming to this dashboard is from our own camera, CIFAR camera, on board the vessel that we operate. So the VS7, it means the speed optimization can be shown on the up right of the camera feed. Then on the bottom, you can see the digital twin. And in addition, we will also show the information come from VS6 and VS8. And on the left, right top of this dashboard, you can see the every information you probably need to monitor the vessel, including the recommendation speed, the arrival time, the current position, etc. So CIFAR role in this is to provide a test vessel. Actually, this test vessel is a commercial vessel, so we have to be careful to not basically steer the vessel by the three parties applications. So we will make a separation between the controlling the vessel by the certified captain from CIFAR and also the application that want to be tested for the research and development purposes. So there is segregation here. We are also developing VS5. We are sharing the info, like some info that we are allowed to share with third parties, including the position of the vessel and some camera feed to our exclusive partners. And also we can propagate user input to other net apps. So the visualization, as I said already, we can visualize GPS, situational awareness, speed prediction, and collision avoidance that come from VS6. So that was a very short introduction to the use case of Antwerp. I hope you enjoy it. And if you have any question, please don't hesitate to contact us to get some more information and how your net apps could be possibly integrated into this use case for the future. Okay, I give back the floor to Andreas.
Thank you very much, Anashme. Okay, so if anyone has any questions, we can post them now or later. So I will proceed with our next speaker, Makis Stamatelatos. Please, the floor is yours.
Yes, many thanks, Andrea. So good morning, everybody, also from our side, from Diakinesis. We will present you briefly our profile and our involvement and the warehouse operations as envisaged and targeted to be enhanced by 5G and the platform of Vital 5G. So at a glance, Diakinesis is founded in 1975, headquartered in Athens, quite a few employees and revenue, provides a full range of activities spanning from warehouse, going through distribution and including also repackaging. Our distribution network and warehouses includes 15 warehouses throughout the entire land of Greece, 8 hubs. We're working with exclusive partners and also we're collaborating with 3PL agents. Regarding the market share, you can see that the Diakinesis is on the top of the 3PL market sharing in Greece. Some or quite a few silver and gold awards, strengthening our profile and also our mission in this demanding area. Some Diakinesis volumes from 2020, 1 million inbound pallets, 100,000 stored pallets, the cases, the delivery lines, the routes, the repacked units, all these numbers resulted to a turnover of 45 million euros in 2020. Brands we handle in the sectors of food, households, tobacco, spirits, electronics, e-commerce, textile. Also, the pharma sector is of crucial importance for our business. You can see quite a few well-known or famous brands there, and also notably top 5 multinational customers trust Diakinesis since 1982. You can see this information in the bottom. Although this information should be on the top. As very short introduction about 5G in the TNL sector. So we believe that 5G connectivity is to enable the actual transition of our sector towards an integrated ecosystem featuring cooperativeness, end-to-end activities and applications, and also 5G is expected to move us forward to autonomous operation, to several optimizations within mainly and initially within the warehouse operation, but not only. The target is to expand these optimizations in an end-to-end fashion. So let's see very quickly typical procedures inbound and outbound regarding the warehouse operation, starting from dock management, the unloading, the receiving, and the put away things at pallets to designated areas. Then starting the outbound activity, with the demanding procedure of picking, then the packing, loading to vehicles, and then dispatch in order for the delivery to initiate. So almost in all these demanding activities, as mentioned, Vital 5G and the Akinesis is targeted to involve 5G and IoT technologies and related solutions together with AVGs and 5G enabled user equipments, targeting specific operations either to optimize, to enhance, or to create new parts of the operation. So quite a few services aiming to the optimization as mentioned. Lean warehouse targeting to eliminate of time wastes based on automation of warehouse logistic procedure. We are targeting to repurpose non-value labor via utilization of AGVs. The main enabler, the key enabler, advanced AGV operations. AGVs are envisaged to operate the pallet transport and also to improve the picking process based on what we call follow me function. This is a human and robot collaboration which is enabled via 5G connectivity. The follow me function is very important for us and has been initially tested in a small scale internal, let's say, experimentation within the warehouse with very impressive results so far. Next service, transport route optimization for order picking, considering heterogeneous data sources such as products location, FIFO and FIFO rules, orders volume, final destination of order product type. We are producing tremendous data volumes in everyday operation within the warehouse, and it's a very nice idea to utilize these data volumes for improving specific operations, such as the route optimization within a very big and demanding and complex warehouse. Next service, very important as well, storage location optimization, which is combined with the transport route optimization, targeting improving the picking times. We are also involving historical data and real data regarding order items, order volumes, daily shipments, delivery routes, forecast demand prediction. Just to note another time, the very big data volumes produced by our systems already operating within the warehouse. And last but not least, the remote monitoring and control based on the availability of remote surveillance and monitoring of processes, and also remote overin and handling, if needed, and in every case is needed, of AGVs by human operators. This is to be enabled by multiple ultra high definition streams, which are requiring EMBB slice, and all these services, I have to tell, that are being developed and tested, producing impressive initial results. And this portfolio, let's say, is targeting to further inspire our visitors and our future colleagues here in order to propose additional services within the warehouse operation. And in this context, we'll be glad to receive your feedback and to exploit further ways of collaboration within, of course, the context of the Vital 5G. Andreas, I tried to keep within the time limitation. I assume that I managed it, so floor is back to you.
Thank you very much, Maggie. Yes, indeed. Thank you very, very much for the presentation. Anyone who has any questions, and yeah, we look forward to, as Maggie said, to your collaboration and to hear your ideas. Thanks a lot, Maggie, for the presentation. With that, I would like to proceed to the next presentation. So the next presentation about the NetApps concept modeling and development will be given by Dr. Jadalandi. So Jadalandi is the R&D technology leader in Nextworks. She's active in the research areas of 5G, 6G networks, edge cloud computing, and IoT. She has a long-time experience with European research projects and industrial projects focusing on control planes for multi-technology networks, IoT platforms, SDN and FV architectures for slicing and orchestration in 5G 6 infrastructures. She's contributing in ETSI MEC, participating to specialist task forces on the MEC Open API definition and testing. She's currently serving as technical manager of the Horizon 2020 Vital 5G project and the ESA ARTES Anchor projects. With that, I would like to give the floor to Jada, and thank you for your presentation.
Many thanks for the introduction, Andreas. Let me share my screen. Can you see my screen now?
Yes, thank you very much.
Okay,
yes,
perfect. So in the previous presentation, we have actually seen a couple of concrete examples of services that can be implemented and tested in our platform, of course, within the context of our testbeds, reusing the tools that we are providing within the system and interacting with all the devices and the 5G infrastructure that we are offering as part of our 3 testbeds. Now it's time to go a bit into the technical details about what an ETAP is, how we can model an ETAP, how we can develop an ETAP so that we can compose them in the target services that then will be tested and validated on top of our system through the Vital 5G experiments. So in terms of agenda, I will briefly go through the concept of NetApps, and then I will explain how to model an ETAP. This is basically what a third party should do in order to create a new NetApp and to onboard that in our catalog so that it's ready to be composed with other NetApps to create a new vertical service and to experiment it in our system. And then some practical hints and suggestions about how to develop an NetApp so that it's ready to fully exploit the capabilities and the features that we are offering in the Vital 5G platform. So going to the NetApp definition. Well, basically, an NetApp is an extension of a virtual appliance, of a virtual function. This concept is somehow extended in 2 parallel ways. So first of all, the NetApp is somehow associated to some service level informations that are supposed to simplify the reusage of the NetApp in the context of multiple services and the possibility to share NetApps coming from different vendors and to compose them in multiple vertical services that could be designed easily by a service provider, simply reusing NetApps coming from our catalog and of course giving the possibility to third party to develop new NetApps that can be used as components of these vertical services. The second point that is quite fundamental in our project is the possibility for the NetApps to use the 5G mobile connectivity. In this sense, it's possible to define a number of requirements in terms of traffic profiles for the various 5G network slices that we can offer in our system. We have seen a couple of examples. For example, the video cameras that are producing the streaming of data. Of course, we will need network slices that are compliant with the EMBB concept, so the enhanced mobile broadband services. At the same time, within the same service, we may need to send commands in a reliable and low latency manner. So this means that we will need an additional network slice that will be based on the URLC profile, so the ultra reliable and low latency communication profile. So everything can be defined in the context of our NetApps so that the system will be able to automatically configure the 5G infrastructure in order to provide you with a virtual environment that is fully compliant with your requirements. At the same time, we are also offering a number of tools that are facilitating the definition of the NetApps, their provisioning, their sharing, and also their validation. So starting from the beginning, the design, we have defined the concept of NetApp package and NetApp blueprint that allows to describe the NetApp characteristics and are used to easily distribute NetApps in our environment, of course, as part of our NetApp catalog in the VITAL-5G open online repository, so that these NetApps can be discovered by other users and can be used to build and create new vertical services in the transport and logistics sector, but not limited to that, of course. There is also the possibility to provision dynamically and fully automatically the NetApp in the virtual environment, the edge and the core, of course, to integrate that with our 5G network slices. There are some validation tools that allows to verify the performances of the NetApps based on the monitoring data and KPIs that have been declared in the context of the NetApp blueprint, and there is the possibility to fully automate the experimentation procedure so that the NetApps can be automatically tested and the related validation results can be evaluated through our components, for example, in terms of results analytics or automated diagnostics. In this case, also helped by some AI and ML procedure. Well, going a bit more into the details of how a transport and logistic end-to-end network service and vertical service is composed, as you can see here, a service can be defined through the composition of different kinds of NetApps. Again, they could come from different vendors, and this means that third parties can easily enter this ecosystem, provide their own NetApps, combine them with existing one, and test them together with all the components that are composing a service. We have application-specific NetApps or application-agnostic NetApps. So we support both NetApps that can be applied to several sectors, not only the transport and logistics ones, that can be easily reused within the context of several services. At the same time, we can also support application specific NetApps that are specific to a given service, for example, related to the control of a specific vessel, related to the visualization of specific data coming from a vessel, coming from the logistic factor, and so on. Multiple NetApps can be basically channeled together in a flexible and fully reconfigurable manner. And this provides basically what we call the end-to-end transport and logistics services. And here you can see an example of that. Well, how the composition of NetApps in transport and logistics vertical service work? Basically, the NetApps are the components of the services. They are usually developed as service components. So they are basically offering some interfaces and they are consuming other interfaces that can be provided by other NetApps. Their combination can create our transport and logistics service. Actually, in the vertical service blueprint and in the NetApp blueprint, there is the possibility to specifically declare the interfaces and also to give the technical specification of the APIs, for example, the definition of the open APIs. This will basically simplify the implementation of additional NetApps that can easily reuse the interfaces offered by the various components, simply using the Swagger of the open API and creating new clients that can be easily integrated in new NetApps, of course, using the language that you prefer for the implementation of your system. Then there is the part related to the instantiation. So basically, in the vertical service design, you will need to define some variable service parameters that corresponds to the deployment flavors that can be used to deploy the VNF packages that are composing the NetApps. And at the instantiation time, you can provide the desired values for your service parameters, and this will allow you to customize the service, and when provisioning that, the system will select the deployment flavor that is more suitable for your own instantiation. This helps you in basically comparing the performances of vertical services that are using different service parameters, and helps in the tuning of the service for specific operational environment and specific business targets. Let's go a bit more into the details of the NetApps modeling. This is an example of the NetApp package. As you can see, we have the traditional part that is related to the VNF package with the VNF descriptors and the list of the software images. We can support both VM-based and container-based NetApps. And together with this, we are defining the NetApp blueprint. The NetApp blueprint includes actually all the NetApp metadata that helps in the definition and the description of the NetApp's characteristics, for example, their features, the category, the description, which are the components, which are the endpoints, and so on. The components and endpoints basically defines how an NetApp is structured and which kind of endpoints it offers towards the other NetApps or to the 5G network. In this sense, there is the possibility to clearly identify the 5G network requirements. This is done, for example, defining the slice profiles that we are expecting. This can be done for the EMBB and the URLC slice, depending on the kind of requirements that you will need. And then there is the possibility to identify the KPIs that should be monitored and that should be guaranteed and evaluated during the experimentation phase of the NetApps. Again, you can automate all the testing phase. This can be done through the definition of some test cases and test scripts. And since we are really keen to host also NetApps that are coming from third parties that may have their own, license strategies and so on, well, we are also offering the support for NetApps that are not open source. And so in this case, there will be some procedure to process basically the licenses and to verify the possibility of the different users to actually use and instantiate these NetApps coming from third parties. Finally, the software documentation that again is the key to enable simple reusage and integration of the different NetApps in third-party services. Well, this is just the information model, the detailed one of the NetApp blueprint and NetApp package. Of course, I'm not going into the details of this. We have several documents available also in our website, in particular the deliverables from Board Package 2 that are giving you a full detail of that. Let me just give a very simple example of NetApp blueprint that in our case is provided in a JSON format. This is basically the data model that we are using. As you can see, we can define the high-level characteristics of the NetApps, the components of the NetApps and the endpoint. The endpoint are used to stitch together several NetApp, and in case of 5G access, we are able to associate to this external endpoint the 5G slice profile. Here you can see a couple of examples of the parameters that can be defined, for example, for the EMBB network slice and for the URLC network slice. Of course, you may define multiple endpoints with each of them with a different slice profile. We have seen before the example of an NetApp that was basically consuming both EMBB and URLCC services. So it's possible basically to define different endpoints to define different network slices for each of our NetApp and each of our services. Then there is the part related to the metrics. So basically what you will need to monitor to evaluate the performance of your NetApps. This is just a quick example of infrastructure metrics related to the networking. So for example, the user data rating downlink, in-app link, the latency, the reliability, the availability, and so on. And since we are considering also the virtual infrastructure in terms of computing resources, we have also the possibility to monitor, for example, the usage of the CPU, the usage of the memory, of the disk, and so on. And this can be somehow used as triggers for the automated scaling procedure. This is the definition of the blueprint of the vertical service, where basically you can put together several NetApps. And again, the full specification for both vertical service blueprint and NetApp blueprint is available in our deliverable D2.1, also with a couple of examples in appendix, and you can use them as starting point for defining your own NetApp. This is just a simple example, just to give you a concrete view of how a vertical service and a NetApp can be represented. So here we have a simple vertical service composed by 3 different NetApps. One of them is attached to the 5G network, as you can see here. This is the IoT management platform that is basically consuming and collecting data that are produced by this local IoT supervisor installed on field. The data that are collected here can be made available through these different endpoints, so that they can be consumed by other NetApps. In this case, a fault detection and predictive maintenance NetApp and a technical data visualization NetApp. Internally, a NetApp can be composed by several components that in our case will be, for example, virtual machines in this particular implementation, but again, you can also use containers. So this is just an example. So we have a message broker, a data store and dashboard, and an IoT event and alarm manager for the internal processing. We have some hardware dependency and NetApp endpoints. Basically, the NetApp endpoints definition allows you to define the 5G service profile, while the NetApp hardware dependency gives you an idea of the entities and the devices available within the testbed that we are interacting with. Here we have the list of the NetApps and services that we are developing within the context of VITAL-5G. And most of them can be reused. They will be available in the VITAL-5G open online repository. So if you are a service provider and you are interested in composing a new vertical service, simply reusing our NetApps, you can refer to this list and put them together in a new service. Otherwise, you can also develop your own NetApp, and again, you can create a new service using just the NetApps that you have developed or combining them with the existing one. Just some practical hints. This is my last slide on how to develop services and NetApps in the context of the VITAL-5G, where the first thing to do is, of course, to design your end-to-end vertical service and the features that this service should offer. And this will also help you to identify which is the VITAL-5G testbed that you can use as target for the service provisioning and the experimental validation. And in this case, you will need to consider, for example, which kind of devices you would like to interact with, which kind of 5G capabilities you will require, and so on. In this sense, it's very important to identify the mobile connectivity requirements that you want to target. So, for example, which kind of quality of service, which kind and which level of coverage you will need, how many network slices and which will be the characteristics for each of these network slices, how many user equipments you will need, and so on and so forth. Then the suggestion is always to decompose the vertical services small and interoperable components that can be deployed as a virtual application. Again, both virtual machines and containers are supported. And we also suggest to check the VITAL-5G catalog for any public NetApp that you can simply reuse and integrate in your service without the need to, implementing something from scratch. So some examples, we have NetApps for the retrieval of sensors data from a VITAL-5G testbed, from Vessel, for example. We have NetApps for data visualization, NetApps for AI and ML training. So most probably you can reuse some of them, right? You can focus your target just on the implementation on the vertical specific NetApps that you would like to focus on. Finally, develop your own application components and try, in this sense, to make the best of the features that we are offering in the VITAL-5G platform. So, for example, you can automatically configure the system and the applications, the virtual application, using the features provided by the OSM orchestrator. All the 3 testbeds are deploying OSM as NFV orchestrator. You can also reuse the public APIs that we are offering to publish and subscribe for the monitoring data. And in this sense, you can exchange data with other NetApps, for example, but you can also retrieve monitoring metrics from the infrastructure, again, from the computing side and from the network side. You can test the deployment, the configuration, and the execution of your NetApps and your own services. And we suggest to do that directly in the target OSM environments. We support OpenStack and Kubernetes as virtual infrastructure managers. And once you have finalized your NetApps images and the PNF packages, network service descriptors, and so on, you can basically define the NetApps and vertical service blueprints with all the metadata that will help in the automated provisioning of the 5G infrastructure and the automated testing in the experiment validation. So just to give some examples, the definition of the slice profile for the various endpoints, the kind of metrics that you want to collect and how you want to process and evaluate them, the kind of equipment that you would like to interact with, the test cases, and so on and so forth. Once you have done all of this, well, basically it's time to onboard your NetApp vertical service blueprint in the VITAL-5G catalog. You can enjoy all our features for the automated provisioning and the experimental validation. And I guess that right now my colleague Juan will give you a practical example on how to use our system, our portal, to onboard new NetApps and to provision them in our environment. This is all from my side. I don't know if you have specific question. I will be more than happy to answer now or after the other presentations. I will give the floor back to my colleague Andreas. Many thanks for your attention.
Thank you very much, Jada. Thank you very much for your talk. Yeah, I mean, if everyone has any questions, please feel free, raise your hand or unmute your microphone. And of course, as Jada said, yeah, we can take your questions later as well. Okay, so if there are no questions now, I will give the floor. Thank you again, Jada, for your presentation, and we'll give the floor to my colleague Juan Brenes. A few words about our speaker. Juan Brenes has received his degree in telematics engineering in the Universidad de Montevideo, Uruguay in 2011, and his master's degree in telematics at the Universidad Carlos III de Madrid, shorthand UC3M, in 2015. At UC3M, his research focus was on BGP, data center architectures, and video streaming applications. And for the last 6 years, he has been working as a researcher and consultant in the areas of NFV, SDN, and 5G technologies for different companies and participating in several EU fund projects. He currently works at Nextworks as a senior R&D systems and software engineer, being actively involved in 5G research projects, amongst them VITAL-5G, 5G Eve, and 5G Zoro. Juan, the floor is yours. Thank you very much for presenting.
Thank you, Andreas. Just to be able to see my screen now. Can you confirm?
Yes.
Okay, so as I was saying, the purpose of this presentation or this video that I will show is to give a really practical example of how you can onboard and a new NetApp in our platform using our portal web GUI, and to show you a really practical example of what a NetApp actually is. And then at the end of the presentation, I will show quickly, very briefly, how we can manage the lifecycle. We can manage the instantiation of a vertical service instance and how this is deployed in our testbeds. Let me just first start here. You can see actually a folder which is at the end what is inside the NetApp that I will use during this example. As you can see, there are three main folders as Java presented before. One is for the licenses, one is for software documentation, test cases, and then the blueprint that Java already described during her presentation. In the license folder, we can find documents that will be used to explain the kind of licenses that are associated with this NetApp. This will be linked with some e-license metadata in the blueprint, as I will show in the next in just a couple of seconds. The idea here is that these documents can help other NetApp or developers and other tenants or stakeholders of the platform to understand what the NetApp, the kind of license that is associated with the NetApp. Then we have another folder which is actually contains the software documentation. This is useful for explaining determine how any other NetApp can interact with our NetApp. In this case, there are two kinds of documentations provided in this NetApp. One is documentation of what the software actually does. It's based on a PDF file. And the other one that we are going to use is an OpenAPI specification of the API interface that this NetApp exposes. For instance, in this case, since this NetApp is mostly about the management of different dashboards for the technical visualization of the NetApp, we can see that there are different endpoints that could be used then by another NetApp to create dashboards on demand or to retrieve information about the dashboards that have been configured. This is just for the purpose of illustrating which kind of documentation we may actually find. And finally, in the last folder that we included, that we envision inside of NetApp, we can provide some test scripts. These test scripts actually, the ones that you see here are actually meant to confirm that the NetApp has been properly instantiated inside the testbed. For instance, in this case, there's just a bash-based script which actually tries to connect back to the management API of this NetApp and confirm that the management API is reachable so that it can be exposed for other NetApps. And the other script tries to connect back to one of the dependencies of this NetApp, which is an IoT device manager, and performs a kind of preparation. This is the NetApp blueprint that Jan mentioned before. As you can see here is a JSON-based file following information model that we established in the deliverables and that you have seen in the previous presentation. Basically, it allows us to provide some high-level information about the NetApp, the kind of metrics that we may want to collect to assess the performance or to assess the KPIs, the kind interfaces that are exposed, the kind of the functional blocks that compose this NetApp, the specification of the interfaces, and some more information. I will go more into the detail when we onboard this already into the platform. Here, as you can see, this blueprint maps the different interfaces to the APIs or to the documentation that I showed before, providing some description about the information that they can actually find there. In this case, this is an OpenAPI-based specification, so it uses protocol HTTP in the data format and so on. This is very helpful for the aim of this is to help other possible NetApp developers to reuse this NetApp as part of other services. And here we can see the link to the licensing information. Then, together with the NetApp, we usually onboard the VNF package. This is basically an OSM-based VMF package that we need to onboard in order to provide the orchestration descriptors that need to be onboarded into the NFVO to manage this NetApp. And the only difference here is that we may want to include some images that will be onboarded also in the virtual infrastructure manager, so that we have the software images once we want to instantiate the NetApp. Then this is a landing page of our portal with GUI. So basically, this is the portal that we are going to use for the onboarding of the NetApps and the management of the service instances and the management of the experiments, and to also visualize the monitoring data and the results obtained during the experimentation with our vertical services. And this presentation we will focus on the part of the design of the experiment, because in that part is where we onboard the NetApps and the vertical services, and we manage the catalog. Basically, here you can see one menu for each one of the descriptors that you can onboard. So basically, NetApps, vertical service blueprint, test cases that at the end provide the script that is going to be run when we execute experiment blueprints that link together the vertical services and the test cases and determine the kind of KPI that we want to measure and the thresholds. We can also onboard virtual network functions, because as we said, the idea is that we will open our platform, so we foresee the possibility that some experimenters will arrive with their own NetApps and will need to onboard their own NetApp packages and DNF packages into our platform. So this is something that we support. And we also have the possibility of onboarding network service into our orchestrators. Once we go into the NetApp menu, you see that in this case, there are two NetApps that have been already onboarded. This is in order to facilitate the composing of and the reuses of the NetApps. So we have some access control mechanisms that allow to determine with which users have visibility over the NetApps that we onboard in the catalog. And here, the user is seeing two NetApps that is allowed to use as part of the services, because they were publicly available. And there's not much to see here. It's just an ID and a name and a version of the NetApp. But if you go into the details, we will see that there's a lot of information that the NetApp developer may use to understand how this NetApp is built and how it might be integrated in a vertical service. As you can see, this is basically what is included in the NetApp blueprint. Basically, the description of the NetApp, the version, the testbed where this NetApp will be available, the kind of access level, which aims to determine the exposure of this NetApp towards other possible users. In this case, it's set as public, so everyone will see this NetApp. It is vertically agnostic because it can be used in a wide set of scenarios. It's as a kind of service because there are several components of this NetApp. It is aimed to be placed on the core because in this case we don't have really strict dependencies on running this on the edge, and we see the endpoints that are associated with this NetApp. So basically, the interfaces that this NetApp uses in order to communicate either internally or externally with other NetApps. And most importantly here, we have the specification of the 5G endpoint. This at the end determines the kind of slice traffic profile that this NetApp needs to be attached to when deployed in a 5G scenario. In this case, you see that the latency that we need in order for this NetApp to run correctly is needs a latency of maximum 60 milliseconds. Then we determine also the kind of infrastructure metrics that we want to collect, and in this case, we establish we will gather the reliability, the latency as perceived perceived on the network, the uplink data rate, the downlink data rate, memory usage of some of the components of the NetApps, basically the amount of RAM that is being consumed by the VMs in OpenStack. And we also determined some service-specific metrics that this NetApp is going to produce. In this case, this is an IoT and an event alert manager. This NetApp produces alerts that could help other systems to determine if there is an issue in the IoT environment. So we are going to measure the amount of alarms that this NetApp produces. Okay, then once we can also onboard new NetApps, and actually I'm going to onboard the NetApp that I have just shown before. Basically, I onboard the package, and I can provide either the BNF descriptor or the BNF package to be onboarded. In this case, I just needed the BNF descriptor, so I provided that, and this is going to be onboarded onto our orchestrator. So you can see here the NetApp has been correctly onboarded. This is the one that I have shown before. So basically, the containing only one VM in this case, so it's a simpler NetApp. Once we have onboarded the NetApps that we needed for our service to run, it is possible to chain them together into a vertical service, as just explained before. As in the previous case, there are some vertical services that have already been onboarded into the catalog. In this case, this vertical service is simpler. It's simple in the sense that it only has one NetApp inside, but it is possible to chain them together in a flexible manner. And as in the previous case, we can also onboard a vertical service. In this case, we onboard a JSON-based file following more or less the same specification as in the NetApp, and we onboard the NSDs. So when we onboard vertical service, we establish some policies that allows us to determine which is the deployment flavor and instantiation level that we are going to use when instantiated, depending on the specific values of the input parameters of the vertical service. In this case, the input parameters is the amount of IoT sensors that this platform is going to control and manage. And we establish a range for that, and we associate that range to the deployment flavor and instantiation level that will be used. After that, we will create a specific, let's say, customization of the service that establishes this amount of users. So we will create a vertical service descriptor containing a specific value for this input parameter, and this vertical service descriptor can be used then to trigger the instantiation of the service. This is the set that I was referring to. We can onboard a new vertical service descriptor directly using the portal web GUI. We just select the blueprint that we want to instantiate. We provide a version and a name, a user-type name, the kind of access level, and a specific value for the inputs. In this case, 100 sensors. Once we have the customization established through the vertical service descriptor, we are ready to instantiate the service. And let me show you how this works internally in our platform. We don't have the part of the web GUI ready just yet. We will have this ready in some short time. Here is basically I'm just basically going to use Postman to simulate the REST request that should come eventually from the GUI, but you can see the kind of information that would be expected for you to fill in once you want to instantiate a service. In this case, you provide a description for the instance that you want to run, a name. The tenant ID will be automatically computed from your login credentials. You can provide also some configuration parameters that may be used to configure the different NetApps that compose the service. You can provide some service parameters that we may want to use during the instantiation, and it is possible also to determine the list of user equipments that should be attached to the 5G slice. And if you see here, I'm using the reference to the vertical service descriptor ID that I have just created to trigger the instantiation. Once this is instantiated, and a vertical service is associated with one ID, and this will go through the platform and eventually trigger the instantiation in OSM, as you can see here, and the instantiation of the VMs in OpenStack. In this case, we only have one VM associated with our service, and that is being instantiated. Once the service is up and running, it will be automatically attached to the 5G slides that have been either provisioned or selected to run your service. So basically, given the testbed capabilities, we may instantiate some slides with the slice profile parameters that have been established for the NetApps, or we may select some pre-provisioned slides. And we will configure, the platform will automatically configure the infrastructure to provide the metrics that were described in the NetApps and in the vertical services. So automatically after the instantiation, the platform will start collecting monitoring information, and will automatically create and start reporting about the status of the KPI that have been designed for the service. That is all from my side. I don't know if someone has any question. Some questions.
Thank you very much, Juan, for your presentation. Yeah, please, if anyone has any questions, please express them now, or unmute your microphone. Or okay, thank you again. Thank you again, Juan. If no questions, if we don't have no questions, we will move to the next presentation. So our colleagues from BEA will present how third parties develop their own NetApps. So I would like to just briefly present our three collaborators. Dr. Alexandru Vulpe has a broad technical experience with about 10 years involvement in international and European research projects. His research ranges from algorithms for wireless communications, 4G, 5G, and beyond 5G networks, to big data, security, blockchain, and Internet of Things. He's the author and co-author of over 100 scientific papers related to the big data, security, cloud computing, 3G and 4G systems, as well as machine-to-machine communications. And he has managed and participated in over 35 research projects where he was involved in all of the major technical elements, including being the leader of work packages, deliverable and annual reports editor. Until now, Dr. Vulpe has been involved in collaborations, consortium shaping, and research proposal writing, which led to acquiring funding of more than 25 million euros. Engineer Gabriel Petrescu is a project manager and researcher with BEA Consult, and with more than 35 years of experience in telecommunication in the telecommunication industry, acting in both technical and marketing sales fields. He graduated from the Bucharest Polytechnic Institute, the Electronics and Telecommunications faculty. Through a grant offered by the Foreign Trade Institute of Spain and Telefónica International in Telefónica Móviles Madrid, marketing and commercial planning, he served as a scientific researcher with Research and Design Institute for Telecommunications. He's also the head of the radio and TV department with Romanian Post Telecom, and the commercial director with Telefonica Romania, the NMT 450 national singular operator. And finally, Dr. George Suciu graduated from the Faculty of Electronics, Communication, Information Technology at the University Polytechnic of Bucharest, where he also received his MSc and PhD. He holds a master's diploma in informatics project management from the Faculty of Cybernetics, Statistics, and Economic Informatics of the Academy of Economic Studies of Bucharest. And currently, his postdoc research work is focused on the field of cloud communications, big data, and Internet of Things, machine-to-machine communication. He's also an IEEE member and has received a Type D IPMA certification in project management from the Romanian Project Management Association as an IPMA partner organization. He's the author or co-author of over 60 journal articles and scientific papers presented at various international conferences. He has also experience in project leading and participating in various research projects, including FP7, National Structural Funds, Eureka, and Horizon 2020, one of which is VITAL-5G, with more than 20 years of activity in information and telecommunication systems. Thank you very much to all three of you for the presentation, and I would like to give the floor to you for presenting.
Yes, thank you. So I will start the presentation. Let me just share my screen. Do you hear me?
Yes, perfectly.
Okay,
Thank you very much.
good. Okay, so I hope you see the screen.
Yes,
so,
yes, you can see.
Thank you. Good. So to further the previous discussions, this part is let's say targeted to effectively showing how third parties can develop their own NetApp. So we have two parts. We have just a small presentation related to let's say some insights into the development of the network applications with some examples, and then we will also show effectively how you can link to
maybe
to a
Alex,
NetApp.
the slides are not rolling, so if you want
yes,
to
they are not rolling because I haven't changed the slide yet.
Okay.
So this is the agenda. Just a brief introduction about the use case that we are handling, the NetApp that is running, how you can use it, the technologies used, an example of a showcase of the blueprint, our IoT stack that is powering the NetApp, this vertical specific NetApp, and then how you can receive the information from the NetApp. Just very briefly about our company, we have over 30 years of activity. We have many projects, also both turnkey and research projects, active in many areas from service innovation to communication technologies, learning and training, standardization and project management. And we have many R&D projects, let's say, in different ICT areas. And you can see here a list of the projects that are also linked to 5G, including VITAL-5G. And we have also a good partnership history in Romanian industry and in Romanian R&D areas. Also, we are, let's say, seconded by our colleagues from the Technocol Galați Association. I think Mr. Ionuț Mocanu is here and can say.
Yes, hello, ladies and gentlemen. Yes, I'm here.
Yeah. Right, I can read. So just it's an organization of community interest, and it's actually a digital innovation hub. So they're promoting new economic activities and supporting SMEs for let's say increasing their competitiveness and benefiting from the technology transport. And yes, they do all the things that DIH does, and you can see on the slides: investments and business innovation and so on. Okay, so very briefly about the use case. Maybe you have seen it also in previous.
Excuse me. Of course, I saw on the presentation is my colleague Alina Răileanu, but since I am here only for 2 minutes, just to add
please.
something for Technocol.
Please.
Okay. So we are trying to disseminate information about our project and also the results we have for now. Also, as a public NGO, we tried also to keep posted all local authorities about our project. And this is why, because the area of application is connected to some public bodies in Galați, such as Free Zone or Industrial Park, who are, of course, very interesting in the results of our project and also on 5G communication. This was our main focus, besides universities and small to medium enterprises. Due to our mission, we have a very good partnership with both our universities in Galați, the Lower Danube University and the Danubius University, and also with the National Association of Small to Medium Enterprises, to which we have agreed to have a partnership and a workshop strictly on this project. I want to say more about this because it was our, let's say, activity in the project, this dissemination and information of the results, publication, and all these things, events. So we had on our other European projects where we are involved as leaders, leader or partner. Every event was also had a presentation of VITAL-5G. Every event of Technopol, of course, contains a small presentation of our project. Furthermore, you will see, I saw already in Mr. Vulpe presentation about the project with Navrom, with Galați Port. We have a common project with Lower Danube University regarding the results from the station we acquired on the VITAL-5G. With some sensor air measurement station and water measurement station. So together with Bea and Navrom, we'll have a site, and from now on we can monthly make some collecting data from air and from water on this two station, which is for us, because until now we were involved only in dissemination and information, and hopefully starting from now on to be involved also a little bit in development due to this acquire of this system of sensors. I think I hope I covered for Alina. Thank you all for listening. Thank you for the work you've done on this project, and I hope Technopol Galați can bring some useful events and dissemination for this project. Thank you all.
Yes, thank you, Mr. Mocanu. So as Mr. Mocanu mentioned, this is the Galați Danube Port trial. So we have a series of KPIs. They will be further presented, I think, in the second part of our workshop. So we're not going to go into too much discussion. Just to know that there are some KPIs, both technical, which you can see on the left-hand side, and business and service KPIs on the lower left side, related to the port. So the ship is, let's say, it has installed a series of IoT devices that are communicating via 5G together also with cameras. So you can see here they are already set up. They are transmitting, and we have a NetApp that is already using them, and it can provide data to interested third parties. We also have video streaming and so on. So as I think Jada mentioned, so a NetApp is can be, let's say, a small atomic component that does one single function and does it well. So we can showcase the onboard data collection interface and interfacing for our for the Navrom vessel, Navrom being the company that operates in the Galați port. So basically what it does, it collects data from the onboard sensors. You can see here the IoT devices that are being used. So data such as water speed, water depth, outside, inside temperature, and so on. And it is made available both for the local onboard server and is interfaced to the edge nodes and the 5G network. So we are going to see this in the second part of this presentation, and we're going to see exactly how the data can be well, how it can be collected, and of course how it can be further used. So basically, the core data collection is consisting of a series of software and scripts. So we have a Node-RED flow that collects the data and it transfers it to an MQTT broker. And from the MQTT broker, it goes to an InfluxDB, which is used as a database for storing time series. And we can also use Grafana server for simple visualization and alerting. So all of these are communicating via IP, and you can, let's say, tap the data at any level. So you could connect in theory to the InfluxDB to get the data, or you can connect directly to the MQTT to get data, or you can simply use Grafana for already seeing some graphs. The NetApp, which is actually codenamed VS9 in our project, is can be used for, let's say, enabling higher different services. An example here is of accurate electronic navigation maps creation, where the NetApp sends the data from IoT sensors and video data and so on, which is then picked up by another vertical agnostic NetApp, which will be presented, I think, in the second part of our session, to process the data and to determine, for instance, the safe distance estimation, which is required for the navigation of the vessel. This is just for illustrating a more complex architecture of the VA2, and I think my colleague Atina will, or Aristotelis from intelligence, our colleagues from intelligence will tell you more about this. We use only open source technologies in our NetApp, so there are no licensing issues. They can be the NetApp can be deployed, and any interested third party can use it. This is an example of the blueprint of our NetApp, which basically describes the infrastructure metrics, the application metrics, and the series of components that are used in the NetApp. So actually, let's say the core part is what we call the IoT stack, and it is available. If you go to the GitLab, to our public repository, you can get it from there, and you can download it and you can deploy it. It has instructions on how to build it and how to run it, and you can see also some examples here. We're not going to insist here because we will show it a little bit later. And also you can use a client. For instance, we use an MQTT Explorer client to connect to an MQTT broker and to receive the data. And you can see here some showcasing of data that is being sent. But this is let's say let's do less talk and we can show a little bit. So we are going to do something very risky and do a live demo now. So first, what I want to show you is actually how to install the IoT stack. So I'm having here a Linux server. Okay. Okay, and as the instructions in the GitLab show, all I have to do is to compose the Docker, and therefore I have deployed, let's say, the MQTT broker and the InfluxDB and a script that gets the data from the MQTT broker and puts it in the database. Good. So since we have the stack, all we need is some data. First, we're going to show you how to generate your own data. So also in the repository, you have a data generator. It's a Python script that generates the data. And if you don't have, let's say, access to the real data coming from a facility, for instance, you could use this this script so that you can generate your own data. So here you can see an example that we are publishing on a topic. It's well, we didn't insist on the naming, so it's use case 2/ship name. So it's a JSON with some values of the data from the IIS transponder, from the depth sensors and the speed sensors. So every 15 seconds, data is coming. We can use, let's say, we can use a subscriber so that we can subscribe to the MQTT, and you can see here that the data is being received. So I'm using a command line client. Unfortunately, the MQTT clients seem to not be working. So this is from the Mosquitto client's official Mosquitto official client. Okay, so this is now, let's say, any interested third-party developer, which of course can implement his own MQTT client, then he can subscribe to the to, let's say, any topic of interest, and then he can get the data and he can do whatever they want to develop. If they want to have real data, in this use case, for instance, we're going to stop the generator. Okay, we still have the IoT stack running, and now we're going to have to connect the IoT stack to the facility. So we are doing this by using Node-RED. Node-RED is a software, I think Node.js based, that allows you to do some very easy flow programming, very visual. So it's available in the Docker Hub. Oh, I'm in the virtual environment. It's available in the Docker Hub. So we just run it. We have a container that is now running. And I think we can do something like this. We can connect to it. Right? So it's a flow. The flows can be easily imported and exported. So we have a flow that is already being made available. I'm going to copy paste the flow. Just a second. Right. So it's available usually as a JSON file. I don't have it on hand, so I will just copy paste it. You can also select it if you have it on your PC, right? So it's imported. Is the VITAL-5G data generator. We have a series of receivers that are, let's say, programmed so that they can receive the data from the sensors in the experimentation facility, and then we have the publishing to the MQTT server. So we are going to modify a little bit the script because it's targeted to a production environment. So we're just going to put local host here. So you can modify the script. And we are deploying it. Unfortunately, we see that we have some issues with the disconnection, but we know that our broker is running. Let me check again if our broker is running here. So it's running, so we have some issues. So you have to know here that because of some issues with this Node-RED flow, it won't work if you put the localhost address. You will need to put the actual IP of the machine. So I'm putting the IP of the machine that I'm running. And we need to deploy it again, and now it is connected. So now the sensors that are coming from the ship should flow into our localhost MQTT. Of course, we won't see it immediately because they are coming every 15, I think 15, every 15 minutes. However, I think we have it configured in our laboratory VM. In our laboratory VM, we have this MQTT Explorer, and here are some messages that have come 1 minute ago. So 1 minute ago, we have a few messages. They are coming in batches. So we have one message which is related to the battery. We have another message that is, let's see, wind. I think it's this one. So we have a few. Sorry, I think it's water depth. pH.
Double VT means water temperature, yeah.
Water temperature, yes. Okay, yes. So these are real data coming from the ship, which is in our internal VM lab. We are still working on this. We need to bring it to the, let's say, the VITAL-5G VMs, which are operated by our colleagues from the mobile network operator Orange. So we're still working on that, but we have it as soon as possible, and from then on, any interested third party could take the data and develop their own applications. Of course, not only third parties, but also other net apps can use the data and perform other functions. And I think you will see this in intelligence presentation. So yeah, I think this is all for now. If my colleagues would want to add something, please, or if there are any questions.
Thank you very much. Thank you very much, Alex. Thank you very much, everyone, for the presentation and for providing your inputs. And yeah, it was very, very interesting. Thank you very much. So as Alex said, if anyone wants to ask anything, have any comments, I guess if anyone wants to ping you offline, they can, right? I mean, to contact with any questions.
Of course.
Perfect. Thank you very much. If no questions, I would like to just make a small request on my side. We have created a survey, a workshop survey, which will also be disseminated at the end of the of our workshop, but it can be found here. So we'd really like to get your opinion about how you would like to experiment with us and at which side, and also give us a small input that will help us organize better in the future and more events. And so please, I've put it in the chat. I've also put a link to our repository that Alex presented before, and for you to access. It's an open source repository. And so we'd love to get your feedback and to work with us. So with that said and done, we have a coffee break. Let's put it's 10:50 CET. So let's reconvene back at 11. The call will stay open, so anyone can stay on, and please don't leave if you don't want to. And we'll be back in more or less 8 to 10 minutes to start with the second session, with the second part of the workshop. Thank you very much again to all of our speakers in the first session. And yeah, see you all later. See you in a couple of minutes.
Testing microphone, can you hear me?
Yes, Telis, we can hear you.
Thank you, Nelly.
Okay, hello everyone. Welcome back. Hope you had the chance to have a coffee, stretch a little bit. So I will suggest to go along with the second part of our workshop. So I would like to welcome to the workshop our next speaker, Aristotelis Margaris from Inselcom. I would like to just give a few words about our speaker. Aristotelis Margaris is a big data and AI solutions architect at Intelligent PC, Greece. He received his BSc and MSc degree from the University of Piraeus, specializing in digital communications and focusing his research on 3GPP radio technologies. He joined the University of Piraeus Research Center and conducted his PhD research on the management of cellular networks with machine learning techniques, and was soon part of the founding team of Intelligent as a developer for cellular network simulation and real-time optimization. He's currently involved in the architecture design, pre-sales and delivery of the company solutions for telco operators, Run.ai suite, which includes functionalities such as network KPI prediction, traffic performance, that monitors predicts traffic and performance, spectrum and rollout requirement analysis, predictive capacity planning, geospatial correlation, and advanced reporting user interfaces. He's also involved in the company's Horizon 2020 and general youth-funded activities, indicatively 5G FOSS, Locus, and VITAL-5G, as a technical manager for software-defined networks, telecommunications, and applied AI for localization, geospatial analytics, and smart logistics. And with that, I would like to give the floor to Aristotelis. Thank you very much for accepting to present, and the floor is yours.
Hello. Thank you very much for the warm introduction. Let me start the sharing. I hope that you can hear me clearly.
Yes, very clearly.
Let me check the controls. Okay, so we have drafted this presentation in order to give third-party groups a good idea of what it means to develop a vertical application on top of the VITAL-5G testbed that revolves around predictive analytics, and it has heavy processing of input and output data from the various pipelines that derive from the testbeds. So the outline of this presentation would be, we will give you a general overview of what the context is for the vertical application 2 and for the use case 2 that is served on top of this vertical application. Of course, we will give you the most relevant information about the testbed, Galati port, which is essentially our data input to all the developments that we are performing here along with our colleagues from Bayer. And then we will dive into the vertical application 2. We'll go a little bit through the functional description and architectural design of the solution. And then we will go step by step to showcase you how we developed our vertical application and what steps have been taken, what sort of software we have used to assist us with the various steps. And in the end, we will focus more on the artificial intelligence aspects of the vertical application and the libraries and capabilities that the vertical application is providing to the testbed, so to third-party users that will utilize the extended data that come from artificial intelligence. So let's go into more detail. The Galati testbed essentially targets some scenarios that revolve around naval fleet navigation, collision avoidance, adverse condition broadcasting, and use cases for emergency messaging. As you can see here, we can identify that there are some problems with the vessel navigation. For example, we have some areas that are very difficult to navigate. We can see it in different contexts, like in AIS data or from IMAP data. And the idea is to be able to develop solutions that provide improved navigation in these areas by using historical data, predictive data, and joining of various data sources, heterogeneous data sources that come from all the different sensors of the area. Here is the blueprint of the solution. We can see that the idea is that to be able to utilize raw sensor data from various sources to put them through cleaning and ingestion pipelines and aggregate them all together into a data lake that is controlled by the testbed below the hood. In this zone, we try to create a mechanism to fuse all the data together in order to generate solid, compact data sets that can be used as input for more advanced techniques like analytics or AI. So in this case, the next part is to consume this federated schema information into a forecasting model engine that consists of some subcomponents for auto-tuning. Auto-tuning essentially means that we want to give the testbed users the capability to have predictive KPIs, but to remove the complexity of configuring these models themselves. So essentially they can request for forecasting of specific KPIs that are generated in the testbed, but the actual details of how the forecasting will occur and how the best model will be utilized are abstracted from the user. And this is something that we believe that will give a lot of value for use cases and other applications to build on top of it. So let's go a little bit step by step what the data pipeline is for the system architecture of the system. We begin by interfacing with the Node-RED and the MQTT information that come from the testbed of PEA. They have various sources, as our colleague has showcased in the previous presentation, from sensory data, from image data, and from other real-time sources. We ingest all this information after we do a little bit of cleanup and processing, and we place all this information into the next component, which is the data persistent component. But before we do it, we push all this information through the data fusion module, which essentially generates a temporal and spatial index for all this data to assist us with grouping this information together in a more efficient way. This temporal spatial index essentially uses the latitude and longitude of the measurements as well as the time to deliver the data into what we call spatiotemporal buckets. These spatiotemporal buckets are aggregated blocks that correlate measurements in the same, let's say, geographic area, 100 meters by 100 meters, and a temporal window of 15 minutes. So in this case, we are fusing all this information from the various sources in this schema, and all this essentially lands in the data persistence module, which is based on Apache Hive. It is a big data lake technology that is optimum for large amounts of data that have heterogeneous schemas and forms. We will showcase a little bit some of the samples of the schema, which is based on cells that include JSON values with different data models. Here we want to showcase a little bit the systems that are running on the hood, below the hood. Top left we see the Grafana dashboard, which is essentially where the data source that we try to parse and we ingest into the testbed. We can see that it provides its own web user interface for data quality right at the generation of the measurements. And then we are moving on to the technologies of the data lake, which split into three different categories. We have the Apache HDFS, which is a distributed file system, it's one of the state-of-the-art distributed file system that sits on the data layer of big data database systems. And then we have the two components that are related to the Apache Hive. We have the Hadoop Yarn, which essentially is the executor that generates that performs the ingestion and inserts the data into the Hive tables. And then we have the Trino.io. It is an external system that it is a very good solution for a distributed query engine. So we use the system to read the information from the data lake. Essentially, we're using two different systems, one to write and one to read from the data lake. Then, as I mentioned before, we have devised this spatiotemporal joining schema, which is ideal for cases where we want to aggregate different sources of data that all have temporal and spatial information. We gather all this information with different schemas in the same vault, what we see here in the screen, the vault data, and then we can request for a materialization operation. Essentially, we can request whatever KPI we want to be generated into a two-dimensional flat file, flat table format, to be used as a data frame for an input for any of the artificial intelligence operation. Here we can see an example of this schema. With the green highlighting, we see the columns that are part of the spatiotemporal join. We see that we have the raw information, timestamp, latitude, and longitude. But also we are generating this date underscore m, date underscore md, date underscore mdh temporal indexes, as well as the big raster x, big raster y, and raster x and raster y columns, which are for the spatial indexing. And in the column in the center, where we see metadata, we have the raw information as it derives from the sensor. The system is ready to process this column, even if it looks to be in an unstructured form. It's based on Apache Spark, which is a technology that is optimized to process this kind of information. And now let's move on a little bit on the artificial intelligence part of the implementation. Essentially, we are using this pipeline for two of our vertical applications as a part of the VITAL-5G collaboration. But in this presentation, we will focus on the supervised modeling perspective. And we will also say a few things about the auto-tuning engine, which is the auto-tuning engine and the machine learning registry, which are supporting components for both of the use cases. Now, for the forecasting use case, essentially, for the vessel trajectory prediction component, we require to have an automated forecasting unit that will test different types of autoregressive models, find the optimum one, and be able to generate a forecasted trajectory for the running vessels of the river. So to do it, we will have to perform some transformation on the location data acquired from the spatiotemporal schema in order to transform it into a single input, single output forecasting autoregression dataset. And then we will use the forecast along with the confidence probability that we have for each different trajectory to test it against existing boundaries of the river or detected shallows that happen in like the shallow that we saw in the image before. Essentially, we want to include all the state-of-the-art in machine learning models based on Python libraries like TensorFlow, scikit-learn, extreme gradient boosting, and Prophet, as well as the most modern deep learning models like PyTorch. Just to give you a small idea of how the model works, we transform the dataset as it derives from the spatiotemporal join. We transform it into azimuth angle or bearing angle, and then we generate a differentiated column, which is a delta theta. Delta theta means how the trajectory of the ship changes with every measurement. And then we use the delta theta as an input variable for the autoregression. Using the delta theta in conjunction with the average velocity speed of the vessel allow us to create more long-term forecast rather than the next position. And what you can see below is the initial delta theta to the left of the graph, and to the right we see the forecasted delta theta along with the confidence margins that the algorithm provides. So we could test for the different delta theta based on the 25% confidence margin or the minus 25% confidence margin or whichever intermediate confidence margin we would like. And we could see with what probability the vessel could have a collision with any of the obstacles that are listed in the system. And also, we would like here to showcase a few of the capabilities that are provided by the testbed with respect to the auto-tuning and the ML registry. Inspired by MLflow and including the MLflow lifecycle operations, we have developed the system in order to be able to generate different types of scenarios of the models and evaluate their parameters in order to identify automatically the best model for the use case. So we wanted to give the user an API that is so simple that he will just select the KPI, in our case being the delta theta for the trajectory, and just select that it would like to minimize the mean square error, for example, of the prediction, and allow the system in the background to find the best model that will resolve this issue. So we can see in this screenshot that the automated ML generates all the artifacts. It generates the input data, the output data, the confidence intervals, and some images that are for debugging, persists the model in a pickle form or other serialized object form, and essentially integrates seamlessly with MLflow to do this background experiment generation and provide to the experimenter with the best optimum model for and also predictions for to build a use case on top of it. Here we have listed a little bit an overview of all the solution, all the included technologies of the solution, starting of course from our partners on Beia that provide us with the WebRTC, Node-RED, InfluxDB, and Grafana system. Every partner that is involved in this is using Dockerized, containerized implementations of their components. So it's something that allows us for easy migration, easy DevOps, good environment separation, and low visibility of the complexity of this component. And then we are moving on with the custom technologies that we use for the API endpoints, which is Node.js, Java, Swagger, OpenAPI and FastAPI for the Python side. And then we have the real-time message queues, Apache Kafka, RabbitMQ, as well as the big data lake technologies, Hadoop HDFS, Hive, and Trino. And we're using some supporting components, that is Apache Airflow, MLflow, for the orchestration of the data operations and the AI lifecycle. And finally, as I mentioned before, for the machine learning models, TensorFlow, Scikit-learn, Extreme Gradient Boosting, and Facebook Profit Library. Just to give you
Aristotelis, I think we lost you. Is anyone else having this problem?
Yeah,
Yes, same here.
I'm having
Same, yes.
Oh, okay. Aristotelis, if you can hear us, try to reconnect your microphone, maybe.
I think the entire connectivity is gone since the screen seems also frozen.
Yeah, yes, you're right, Jada. I think you're right, yeah.
So maybe we could move on with the next presentation.
Yeah, yeah, you're right. But now it's completely, yes, you're right. Okay. Yeah, apologies for that. This happens in live events. Okay, so until we can get back the connection from Aristotelis and maybe he can continue later, let's move on to the next talk by Nina, to which she will be explaining how the data is consumed from the VITAL-5G platform. So Nina, the floor is yours.
Thanks a lot, Andreas. Let me again share my screen. Okay, I hope you can see my slides. So,
Yes.
Thank you. Perfect, thank you. In this presentation, we will show you the recent updates on how the data can be collected from the VITAL-5G pilot sites, how we do that, and what type of data can we collect and what type of metrics, to give you a short intro of what can be collected as well. So since our overall ecosystem in VITAL-5G is very distributed, we have 3 different testbeds deployed in 3 different pilot sites. We decided to have one centralized monitoring platform within VITAL-5G platform to use it for collection, storage, retrieval, and visualization of the data being collected from different pilot sites. And for that purpose, we define also different types of data that can be monitored, such as network, platform, infrastructure, and service-related metrics. Of course, all that data that we collect is to learn about the performance of the NetApps and the vertical services, and to learn about the 5G network and 5G improvements that we bring to the vertical services by using 5G standalone deployments.
Nina, I'm sorry for the interruption. It's Arsoteris from before, but I had a blue screen error and it shut down. Sorry for the interruption.
No problem. I think, yeah, we can close this presentation and maybe come back to you in a few moments.
Sure.
Okay, yeah. So I will then continue with my slides, and then when I finish, maybe we can come back to you. So for this centralized monitoring platform, we decided to collect data in a unified format. So the sources of our data are distributed; they're completely different. We have a 5G testbed in Antwerp, 5G testbed in Galati port, and we have also 5G testbed in Athens. And to be able to collect data from such distributed environment, we have defined a unified format for all the local monitoring system running in each of these VITAL 5G testbeds, but not only focusing on the network platform and the infrastructure metrics, but also NetApp related metrics and service related metrics, allowing NetApps to also have some service monitoring capabilities and allowing them to push the data towards monitoring and helping us to monitor their performance and their needs. So to do that, I will show you how our architecture looks like. I will not go into detail how we deploy different components and how we design them. I will just briefly explain how the whole monitoring looks like. So first here we have the internal components of our monitoring platform. We have storage to store the data. We have different APIs defined for configuring the topics. Then we have message queuing systems. In particular, we use 0MQ for this purpose, and we use Postgres to collect and measure and store the data. To interface with the external entities, we define APIs, and in particular, for the first touch with a platform is to, of course, to define the topics where the local testbeds will publish their data. We define the interface with the, for example, experiment lifecycle manager. So when you define your experiment to run on the VITAL 5G platform, then you need to define which metrics you want to measure, and then interfacing with our monitoring system, we together define the topics that will be used and exposed to different testbeds for monitoring that particular type of data. So once the experiment lifecycle manager creates the topic or sends the request to create the topic, our monitoring platform creates this topic and distributes that information to a respective testbed which is selected for that type of experiment. So for example, if you want to do an experiment of for example, using a testbed in Antwerp, you define the topic that you would like to use, meaning you define the testbed which you want to use. In this case, Antwerp, you define which type of metric do you want to measure. For example, if this is a network-related metric, this could be, for example, throughput on the uplink or latency, end-to-end latency, and this can be specified, and then the topic on which the data will be published is created aligned with that request. So when the topics are created by our monitoring manager here, data collection manager, this is distributed to the testbeds, and then testbeds use their publishers to basically publish data on our platform. Not only testbeds can publish the data, but also this data that is then published here can be used by different components. And in a VITAL 5G project, we have, for example, these two, AI-based diagnostics and results analytics, or it can be any other component that you might like to develop and then to interface with our monitoring system and subscribe to different types of data that we collect. But in particular, these two components subscribe to the data. They get the recent updates, either historical data or real-time data collected from different testbeds. for a particular experiment, they're doing the analytics and they're doing diagnostics for different AI-based algorithms running here in the component. In particular, for this purpose, we also enable storing data so that we can collect data from, for example, for weeks, months, and so that data can be then used as historical data for training different algorithms, or even if these algorithms are not machine learning based, different components can do the analytics over the time, how the different metric has been behaving when the experiment was executed. This is briefly what these components are. So sources of our monitoring data are given here. They are coming from different testbeds in the project, and these are the consumers of monitoring data. And of course, they can also create their own data that can be then further published on our monitoring platform. For example, one of the results from the results analytics could be some analysis that is made, or some additional KPIs and diagnostics that are also created by AI-based diagnostics. So if there is some sort of additional data that needs to be published on our monitoring platform, we also support that, and we create particular topics for that type of KPIs, and we also make it available on our platform. Very important is that we visualize the data as well. I will show you how visualization currently looks like. We use Grafana for that, but of course, later in the project, we are planning to integrate it with the VITAL-5G web GUI, so that everything will be in one place, and also the work on the interfacing between different components and, for example, experiment lifecycle manager with our platform is still ongoing, but soon will be ready for testing. So here we just show the process diagram of different platform operations, how they work. And basically, we just show here what I already described to you briefly when explaining the architecture. So here we start first with the experiment lifecycle manager that creates topics. As I gave you an example, you can define which experiment you would like to run, and then you define what metrics you would like to measure. Based on this kind of request, our monitoring platform creates those topics, prepares for storing data when data is pushed towards the platform or published on different topics. It can be stored. We prefer using a JSON format for collecting this data. So basically, on publishing data on different topics usually comes in a PDU in the format of a JSON object. And then we visualize data, but also make it available on different topics to be, if you want to subscribe, like results analytics, array-based diagnostics, you can subscribe, or they can send requests on the API to get the data. If they are not interested to collect data in a real time, they might be interested at certain moments to retrieve the current value, for example, of latency or throughput in the experiment. That could be also done by sending GET requests, or that if vice versa, if some changes need to be made, or if they want to publish some data, they can use pub/sub mechanism, or they can send PUT requests to update the KPIs on the monitoring platform. These slides will be, of course, available for you, so any details can be then further discussed. You can always contact us for more information. I will just briefly show the types of metrics that we define in the project and that we are either already measuring or we are planning to measure during the rest of the project lifetime. So I already mentioned that we collect different types of metrics. We have network-related metrics, service-related metrics, platform and infrastructure-related metrics. I will just give you several examples of what these metrics are. So network metrics, very self-explanatory, is basically defined. They are defined to measure the performance of the 5G network in different setups in 3 different testbeds. And here is the list of some basic network metrics like throughput, either upstream or downstream throughput, maximum expected latency, network reliability, user experience, downlink data rate. All these metrics can be measured, of course, in all 3 testbeds. And here we define the measurability level and also the priority. Most of them are high priority because we want to learn how the 5G network behaves and how it influences the operation of the vertical services and NetApps that we deploy in different pilot sites. Here we provide detailed descriptions. I will not go through that, but of course we give it to you on the slides, and we also provide it in our deliverables that are periodically being published on the website as well. So please always keep an eye on that for more detailed information. Regarding infrastructure metrics, these metrics are defined to basically learn about the behavior of the infrastructure, of the virtualized infrastructure that we used for deploying our NetApps and vertical services. We always want to know how the computing resources are being used. So we measure CPU memory load, also possibly energy efficiency can be measured, disk usage, the different stress tests can be performed, and then the real-time outcome of those stress tests can be also measured, GPU load for different applications, etc., etc. So basically, here we also define and specify which testbed components are particularly used for that kind of measurements. But just to give you an idea of what we call infrastructure metrics. Service metrics are more vertical service oriented, so they are not, the ones that we define here are not NetApp specific. We call them very vertical agnostic, because they could be applied to any type of vertical service that is using 5G network for its own operation. Here we just give one example for our use case one and vertical service for Vessel autonomous control. We define what, for example, end-to-end latency means, what is the availability of that service. We also measure, for example, we could measure localization accuracy if there is some service running inside a NetApp that is predicting the location of the vessel, for instance, or if it is predicting the speed and defining the optimal speed, then maybe localization accuracy applies in that case and can be measured, or precision of object detection in the case of digital twin, etc., etc. So basically, all these types of KPIs can be also defined by you, and then if you are a third-party experimenter, we can discuss how to measure them and how to then extend the scope of these metrics that we already define and measure in the project. And finally, platform metrics are more orchestration-related metrics. This is to basically understand how long does it take for certain orchestration operations to be performed. We have a separate session today. The last one is the technical talk on the orchestration. So this is basically how different metrics can be used and defined for these operations. How long does it take to onboard NetApp? How long does it take to scale it up or scale it down, or to perform any component associated operation that, of course, takes some time. If any update needs to be made on the NetApp, how long does it take, and how does it affect the operation of the NetApp? All of that, of course, for all that we use open source Nano or OSN component on each of the 3 testbeds to basically evaluate those. Now I will go to the video that we prepared, a very short one, just to showcase how the monitoring system works. I already explained how it works in the background. So here we just show how it looks like and how currently the data can be collected. So here, since we are still in the progress of integrating this monitoring component with, for example, Experiment Lifecycle Manager, we need Experiment Lifecycle Manager to send the request for creating the topic. And to mimic that, that request, we use Postman client here. And for example, if we want to measure latency, for example, in Galati pilot site, we define a structure like this one shown here on the screen. We send the request on for example, on this API version 1 platform infrastructure, and then we define the metric type, which is in this case latency. We need to specify the slice ID for which slice this latency will be applied. What is the unit? In this case, of course, it is a millisecond. We can also specify what use case and what is the metric ID or vertical service instance ID to specify more details about the experiment to which this measurement is assigned to. So once the experiment is created and you want to measure some metric, this is the first step through the experiment lifecycle manager to basically create these topics. And here we show that for all three testbeds, this is for Galati, for Antwerp, and for Athens, the same procedure can be done. It is done from the experiment lifecycle manager. The request for creating different topics is made. And based on this, our monitoring system, when receiving these requests, it configures the topic internally, and then it communicates further through the interface with the local testbeds, 3 testbeds that we have, and they configure further their local monitoring systems to publish data on these designated topics. Here, we just briefly show how the GUI looks like. For that purpose, we use Grafana. So here we can, of course, change the overview and change and fine-tune how the overview looks like. For Antwerp, for Galati, for Athens, we can measure, as I said, any of the metrics that we defined in the tables before. Here is just an example on the network latency and CPU load, for example, for service metrics. So for CPU load expressed in percentage, we can here see how it can be monitored in real time and to in real time monitor the behavior of the, for example, virtual machine or edge component in the testbeds where a particular vertical service is running. And also for the latency, if your NetApp is using URLC network slice, for example, then you can specify that you would like to measure latency in milliseconds, and then this measurement can be also collected from a particular testbed. Here, just a disclaimer, all this data currently is synthetic data. It is not coming directly from an existing experiment. This is just to show you the capability of the monitoring platform. And we are now in the process of testing this tool, and we will make it available for use very soon. In the upcoming weeks and months, this tool will be available. So keep an eye on the recent updates and on the demos that we show on the website, so that you can also keep in touch with us and, of course, learn more about the current advancements and future plans for different platforms. This is all from my side regarding the monitoring tool. If you have any questions, please don't hesitate to ask us now, or you can always contact either me or my colleague Vincent Charpentier from IMEC to find out more about this and to engage with us on this activity. Thank you very much.
Perfect. Thank you very much, Nina. Thank you very much for the presentation. And please pose any questions if there are any questions now, or feel free to contact Nina and Vincent anytime. Okay, so if there are no questions at this point, maybe we can go back to Aristoteles' presentation. If Aristoteles is with us, we can just continue from where you left off.
I was at the last slide, to be honest. I was about to ask for questions. Yeah.
Okay,
so
perfect.
I was just saying that the future steps would be to how we would complete the application, what were the last steps. But other than that, I was about to go into the Q&A section.
Okay, perfect. So then I will open the floor to questions for both Nina and Aristoteles at this point, if there are any. And if not, we can move to our next presentation then. I don't see any hands up or something. So, okay. So we move on to our next presentation. We'll give at this point the floor to our coordinator, Nelly, so that she can present the test beds and trial sites of VITAL-5G. So Nelly, please, the floor is yours. Thank you very much.
Thank you, Andreas, for the introduction again. So I will share my screen shortly. So I hope that you can see my screen now.
Yes,
so thank you, Andres. So this presentation concerns the test beds and the trial sites of VITAL-5G project. Here is a brief view of what we are going to present today. First, we will briefly go through the 3 test beds and the respective transport and logistic facilities and use cases, and then we will dive into the details of each one of the 3 test beds, as well as of the assets available for third-party experimenters per site. The Antwerp 5G testbed is based on Telenet's Innovation Center infrastructure and has been already upgraded to release 16 standalone. The Danube 5G testbed is based on Orange Romania infrastructure with an extension to Galati and is already upgraded also to release 16 standalone. And finally, the Athens testbed is based on OTE's backbone infrastructure, which will be upgraded to release 16 shortly. Here we can see the 3 TNL facilities and respective use cases. More specifically, in Antwerp, we have a mission-critical application regarding the automated and remote vessel navigation, as well as the ports, the digital twin. In the Galati, the use case focuses on the data-enabled assisted navigation, while the Athens use case focuses on smart and lean warehouse concepts and the collaboration between humans and AGVs. Now I will move on to discussing the Antwerp 5G testbed. The Antwerp testbed consists of a release 16 with 5G standalone and end-to-end slicing. There are also 5G radio cells installed in the port of Antwerp, which is the testing area, as you can see here in the figure. And also there is a NetApp Edge platform for hosting and orchestrating the NetApps, which is located at IMEC premises as shown also here. I should mention at this point that the core of the network is directly connected with the NetApp Edge platform. In terms of RAN configuration for Antwerp, the optimization has been completed and there are also 3 G-Node Bs that are up and running with the optimization tests completed as well. In terms of end-to-end slicing, the design of the slices has been completed whereas their configuration is in progress. The core is also configured and its integration with the RAN as well. What is ongoing still is the integration of the NetApp platform and the 5G core. I should mention here that the NetApp platform has an OSM version 10 available and contains and has also NetApps deployed as Docker containers. Here we can see the vertical facilities at the Antwerp testbed. Here we can see the Tercofin 2 vessel, which is 110 meters long and has different sensors on board, such as a GNSS device, providing parameters such as heading, speed, pitch, and altitude, as well as cameras and radar units. On the right hand of the slide, we can see a top view of the vessel and the camera setup. With red, there are denoted the non-static cameras deployed on board the vessel, whereas with blue are denoted the static cameras deployed. In terms of communication system, there is also a 5G modem available and connectivity to 5G non-standalone has been tested. And now we are planning on testing also the standalone deployment. Here you can see a few of the sensors that are installed on the vessel. So we have a CIFAR sensor suite available and also a 5G user equipment as shown also in the picture with trial firmware connected to the infrastructure. So here in the slide, we can see also the infrastructure responsible for sending this information to the network. I should mention also here that there are 2 vertical services the vessel autonomous navigation and the vessel remote monitoring. And here in the slide, we can see how the different net apps are combined together in order to form these two different services in order to provide the envisioned services. Here we can see the available assets per category for the Antwerp trial site. So in terms of NetApps, we have the onboard data collection and interfacing for vessels, remote vessel monitoring, the remote digital twin, and the navigation speed optimizer NetApp. In terms of data, real-time data from the vessels, including their location, speed, and heading, can be provided, as well as real-time calculated optimal navigation speed. For the 5G testbed, as I mentioned also previously, there are pre-configured 5G slices, but new slices can be provisioned depending on the needs of the experimenters. And as Nina also mentioned in her presentation just previously, there are network and platform KPIs that are being calculated from monitoring the 5G testbed. Here is a detailed description of the assets available at Antwerp. I will not go through due to time limitations, but I should mention here that this information will be made available right after the webinar and is also available in the VITAL-5G website. And I will close the trial site with the offering for third-party experimenters. So we can provide, as I said, 5G-based low-latency retrieval of real-time data from parameters that are monitored on board the vessels and can be used as input for new NetApps to predict, for example, vessel trajectories or recommend alternative paths. There are also examples for creating, showing how to create monitoring dashboards that can be used for other use cases as well, for remotely monitored cars, for vessels and drones. The respective visualization environment is also provided, and also the creation of real-time environmental maps for other use cases, for example, autonomous driving or navigation within warehouses. And last but not least, the dynamic calculation of optimal speed of the vessels. And with that, we'll move on to the next testbed, which is the Athens testbed. The Athens testbed has two different sites. So the core is located at OTE premises at Psalivi, and the run is based on the Akinesis warehouse in Aspropyrgos. I should mention here that the 5G testbed at Psalivi is based on the 5G EVE infrastructure, and we hope that it will be upgraded to release 16 standalone by the end of September 2022. I should mention also that the RAN and the core are connected with fiber connectivity, which is approximately 23 kilometers. And there are also in the warehouse two indoor cells that provide 5G coverage within the warehouse demo area. Some more details about the characteristics of this testbed. As I said, there are two small cells that have been provided by Ericsson for covering the connectivity needs within the warehouse. The packet core is a 5G standalone based on Ethernet platform and has two different components, namely the control plane function and the user plane function. The location of the two cells within the warehouse can be is shown here on the figure, and also there is an OSM deployed at OTE facilities with different features for network service definition as well as VNF package generation and a GUI to support VNF onboarding and deployment, and also there is support for various virtual infrastructure managers. In terms of vertical facilities, here we have a view of the demo area at the Kinsey's that Marcus also mentioned in his presentation previously. So the demo area consists of around 1,200 square meters. There are both there's a picking area and a checking area, and there are also inbound and outbound gates as shown also here. And in terms of equipment and systems available in the warehouse, there are RF scanners for picking and packing and forklift operation, as well as the warehouse management system and the enterprise resource planning system that provide a lot of data that can be, let's say, used for optimizing the operations within the warehouse. And also there are electrical pallet movers and forklifts and GPS monitoring and sealing of shipping containers and trucks. So here is the, let's say, the status currently of this trial site. So there has been the identification and the preparation of the trial area. This area has been also digitalized. So we have a 3D digital twin of the demo area. And the Kinsey's has provided also historical and MIS data for the NetApp's development. There is an HGV and a weather and environmental telemetry station deployed at the warehouse, and some early testing has been also performed at the trial site. There is also a platform dashboard created for the HGV communication configuration, as shown also in the right hand of the slide. Here are the available assets for the Athens trial site. So for the facilities, there's a digital twin and a simulated warehouse environment, which includes a virtual HGV. There is partial access also to the HGVs. And in terms of NetApps, the third-party experimenters can create and configure an instance of vertical agnostic data ingestion and post-processing NetApps. There will be data available from the mounted sensors in the warehouse, as well as non-sensitive historical data from the warehouse and HGV operations. As in Antwerp here, there are also available 5G pre-configured slices, and the new slices can be provisioned based on the demand. Here we have also the network APIs from the monitoring of the 5G testbed. Here is the description of the assets, as I said also previously, which can be found also in the website. And here is the offering. So Athens trial site offers 5G-based low latency retrieval of data for storing and processing from the warehouse. The setting up and scenarios configuration, as well as the execution of experimentation on the simulation of the warehouse operations for various optimization algorithms for the warehouse processes is supported. The use of provisioned 5G slices in order to test the NetApps that will be developed, and also the collection of network-related KPIs is supported. The last part of this presentation concerns the Danube 5G testbed. So here is some information regarding this testbed. The use case concerns the design and development of a data-enabled assisted navigation application using IoT sensing systems and video cameras installed in the Galati port and on ships and barges. So the Galati port is an entry point for large shipping traffic from the Black Sea towards the continental Europe, and is the largest port on the Danube. So the scope here is to permit a safer port operation and security regarding navigation of ships with the help of assisted navigation, even in severe weather and water conditions. As I said previously, what we aim here is to showcase data-enabled assisted navigation, and real-time control operations that will be implemented by collecting data from cameras and sensors on board the ships that will permit taking navigation and operating decisions based on online analytical processing. And finally, the development of a connected ecosystem in constant evolution with adaptability and transparency. Some information about the testbed characteristics. So the 5G standalone RAN implementation is completed. The core is also finalized, and the OSM deployment as well. The 5G, the Vital 5G platform is hosted in Orange Romania premises, and there has been planned the connectivity between Orange premises and partners. Two slices are currently implemented, namely EMBB and URLLC with validated performance. One device has been validated in the standalone network, and the service slice automation is currently in progress, as well as the monitoring solution for the KPIs as said previously. Here we can see the Kalati vertical facility. So in terms of fleet, there's also a self-propelled fleet and non-propelled fleet. In terms of network, there is a data center for video surveillance and aggregation of the sensors deployed on board the ship. A view of the data center for the video surveillance is also shown on this slide. And there is also a 5G router on the ship providing the connectivity of the ship with the RAN. Here we can see some images about the devices that are used, and also some platform functions. As we can see here, we have the 5G access network and the core network, and also there's the interfacing with the testbed devices, and the different NetApp components for data collection, fusion, as well as data persistence, and the machine learning modules for optimizing and predictive functions. I move on to the available assets on the Kalati side. In terms of NetApps, third-party experimenters can create and configure an instance of vertical agnostic data ingestion and post-processing, and also perform a risk assessment utilizing the NetApps developed in the scope of the project. In terms of data, the positions of ships and obstacles can be provided, and also sensor data such as weather and air quality. Here also there are pre-configured slices, as I said, and new slices can be also provisioned. In terms of results, network KPIs from the monitoring of the 5G testbed can be provided, and also risk analysis data, alarms, and the relevant analytics info that are produced by the mechanisms I mentioned before can be also provided. Here is also the detailed asset descriptions. And I will close this presentation with the offering of the Kalati trial site for third-party experimenters. So 5G-based low latency retrieval of the position of ships and obstacles can be provided, which can be utilized for building new NetApps. These assets can help on improving the decision made in the NetApps based on the diagnosis and monitoring functions provided by access to edge nodes in the 5G network, collection of various experimentation results, the creation of local maps with improved collision detection mechanisms, the retrieval of real-time data streams to prevent dangerous situations, and finally, predictive maintenance scenarios and sanity checks can be supported based on the sensor data for ship safety purposes. So this was all from my side. Thank you very much for your attention. And I don't know if there are any questions for me at this point.
Perfect. Thank you very much, Nelly. Yeah, as Nelly said, a pleasure. Yeah, so if anyone has any questions, please read. I left a link also in the chat where as Nelly mentioned, there are more information. That basically the information that you presented are also part of our website. So if anyone wants to, please do and let us know. We're always at your disposal. So if no questions, I don't see any hands. So if any no questions are not given, I will move on to the last presentation of our workshop. Thank you very much all for staying with us. So the next presentation will be given by our colleague in Orange, Romania, Cătălin Brezeanu. A few words about our speaker. Cătălin is a PhD candidate at the Polytechnic University of Bucharest and is specialized in communications, networks, and software. He's currently involved in the development and implementation of cloud and IoT projects for Orange, Romania. And he's also focused on technological research, participating in Horizon 2020 projects. Cătălin, the stage is yours. Thank you very much for your presentation.
Thank you very much for a short introduction. I will share my screen. Okay, please tell me if you see.
Yes, we can see your screen. Okay. Thank you.
Thank you. So in the following moments, I will present 5G orchestration and slicing according to the VITAL 5G project. I will start by, I will start with some words about the overall concept of the 5G 5G architecture with the main functionality. We have in the center of this entire concept, we have the 5G facilities, like for example, how is Galați and Bucharest facility. For the beginning, what facility we have to offer? So first of all, we will start with the infrastructure. From the computing part, all hardware equipment, routing, switching, network appliances, and computer appliances, radio units, and all configured for the entire infrastructure in order to have the environment to deploy the services that we'll talk in further moments. With this base, hardware base, we apply cloudification principles, virtualization layers, containers, and so on. Also, the respect with this infrastructure, we deploy services, end-to-end network services, slicing that will be capable for the automation processes, scalability, using different orchestrations, platform or software, management, and also lifecycle management. Before the deployment and going to production, we have the capability to test and experiment some validation processes as the user is requesting to support, I don't know, some trials in different areas and some different POCs, monitoring the capabilities and the KPIs, and then configuring in production environment accordingly. And also all these let's say capabilities, type of infrastructure and test scenarios are exposed to the user using different NBAs interface and NetApps APIs, using to expose the service and to expose the infrastructure to the developer and to the user, and the service for the final vertical user. All these NBAs are used to also to communicate between different components in order to integrate all the NetApps necessary in these facilities. Regarding the 5G platform concepts, we have trial facilities, three kind of file facilities: a seaport, a riverport, and a warehouse. Every facility is having a specific 5G enabled use case that is built with the help of the 5G testbeds compliant to the release 16 for 5G standalone. The one in Antwerp, in Danube, and in Athens. On this testbed and facilities, we have the experimentation platforms and the open repository. In one way, will help the developer to onboard the software for into the repository. To be consumed and deployed by a vertical user that is accessing a graphical interface like a marketplace and chooses all the components necessary to build the end-to-end slicing in the specific facilities. Regarding the 5G architecture of the facilities, the functional blocking interfaces, we have a base, as I said before, built in for starting for physical infrastructure like radio, transmission, network appliances, and then virtualization layer that will have also the control and data path separated from the network, virtual infrastructure manager for VNF or CNFs, security functions, and also on top of this, orchestration for the management and monitoring all the KPIs and the policy that we'll need according to the specific service. All the testbeds have this functional blocks in place in different manners, but also they are using different technologies and have different implementation for each facilities. On top of this infrastructure, we have different interfaces and Node-band interfaces that help to expose it to the platform, entire platform, and to the user for different step in the lifetime of the service, like provisioning, testing, monitoring, and so on. From the functional to software architecture, we have the portal web GUI where the user is accessing, is choosing the slice that is needed. Then we will start the instantiating into infrastructure. We'll have NetApps and service orchestration that will help to deploy in specific VNFs and CNFs in the platform. Then we will have NetApp runtime config that will help to config specific services for every VNFs and CNFs. We'll have a blueprint for validation of the result that all the results. And in the next step, let's say a monitoring platform for management for the lifecycle management of the entire slice. For the VITAL-5G third-party exposure in Romania, in Galați and Bucharest facilities and facility and testbed, we have VNF capabilities up to 60 cores per VNF or CNF, 32 gig of RAM and 40 of storage, building up to 200 concurrent VNFs and CNFs. Having a total virtualized infrastructure resources of 3,200 vCPUs, around 6 tera of RAM and 8 tera of storage. And as orchestration, it's MANO compliant OSM release 10 that is also can be used to deploy CNF's applications and software component. As a service, we have automation of the entire network service. We use as a monitoring platforms Prometheus with Grafana and StableNet that can monitor from the physical layer to the user level in every part of the infrastructure. We can expose 5G services from the VITAL-5G platform, and regarding the slice, it can have up to 10 slices MBB or 2 slices from the ULLC concurrent in the same time. In the images below, we have the OSM. With the help, we deployed an instance in production environment for our OpenStack. Here we have a VNF deployed. From the 5G architecture slicing functionality, here we have 2 flows representing two service slices with different QFI. Starting from the UE, the slice is started. Also, it's using the same GNB in order to make the slicing in air interface at the GNB level, and then we will start the flow. We'll continue the flow to the UPF in the 5G SA infrastructure, and to the final application that is needed to be consumed. That is all from my side. Thank you very much for the presentation and for the time.
Thank you very much, Catalin. So thank you for the presentation. Any questions, comments? Anyone? Please, at this point, unmute your microphone. Okay. So I want to, for another time, I thank all of our presenters for their work, for their presentations. It was really great. Thank you very much. Thank you for all the. I think it was we had some very valuable input. I've left in the chat the survey as we discussed before. It would be really great for us if you could fill it in. Get a feel of your needs, what you would like us to improve, how are you going to use the assets so we can provide more services. Depending, of course, on the demand for a specific service, we could add it to our catalog and adjust it to our trial sites. And of course, all the slides will be made available. And if you would like us, I mean, we have the emails of some of you, of the participants, but if you would like it, I mean, please fill in the form, and so we can have your email address and contact you with the slides, which will be made available soon. The workshop will be made available through our YouTube channel. Let me just quickly share the link, actually, for our YouTube channel. Sorry, just give me a second. Okay, I will put in the chat. And thank you, of course, to all of our participants, for staying with us throughout this workshop. We're really happy to have you. We look forward to have you in our future events, and of course to collaborate closely with you. We're all at your disposal. Send us an email if you have any questions afterwards, or for any potential collaborations. We're open. And that is it from me. Another round of applause to our speakers again, and thank you very much, everyone, for being here with us today. I don't know if any of our speakers wants to add something. Please do so. Okay, perfect. Have a great day, everyone. Thank you for joining.
Thank you. So bye-bye.
Thank you.
Bye-bye.
Thanks. Bye.
Thank you. Bye-bye.
Thank you. Bye.